Okay, one thing that you'll need to do for the test is to be able to take some raw data, like I have right here. I have time and I have distance over here on the very right. It says data for calculator. And you're going to have to be able to put those in the calculator and find the equation of the line, what kind of line it is. Remember, we studied four types of lines in class, relationships. That would be linear, which is a straight line, quadratic, which is a parabola, inverse, and the root curve. And so I'm going to go through the steps and show you how to put in the data so you can study that. Anyway, you're going to hit the stat button. See over here at the calculator on the left, there's the delete and the stat. Hit stat, and then you're going to just hit enter because you want edit, and that'll give you some lists. Now my lists are full, so what I need to do is hit the gray cursor keys and highlight L1, push clear, push enter, over to L2, highlight L2, push clear, push enter. Then I'm ready to put my numbers in. So I'm going to put in the time, and time goes on the x-axis. You have to know it goes on the x-axis, the independent variable. I'm going to put those in 0, 1, 2, 3, 4, 5. All right, then I'm going to go over here to list 2, and I'm going to put in my distances. 2, 1.5, 3.9, 11, 22, 38. Enter. All right, so I got them in. Now what I got to do is be sure my stat plot's on. That's right here, over here at the calculator. At the y equals, right above its little blue stat plot. So I'm going to hit second, y equals, and my stat plot is on. I'm going to go ahead and go in. If yours isn't on, you're going to highlight on, press enter. Be sure you're on scatter plot where you want to connect the dots. X list should be L1, Y list should be L2, and I always use the big mark so I can see it. And if you'll hit the zoom button right here on the calculator, right above delete is zoom, hit zoom, and then the number 9, and that'll give you an automatic fit. Now, and I have something in my y equals, so I'm going to go, that's what this line right here is. I'm going to go erase that because I don't need it. So clear, I'm going to hit zoom 9 again, and there is my data points. That looks like a parabola, like a quadratic. So I'm going to go in, I'm going to go to stat, I'm going to go to calc, because I want the equation on the line, and the calculator will do that for me. Now, if you'll notice, you have the first three, 1 var, 2 var, and MED, are all statistical tests. We want to start with number 4, which is linear. Number 5 is quadratic. And then the other one we'll use is power regression, which is way down here at the bottom, and it's the letter A. I went too far, letter A. So what we want to use, though, is the quadratic for this one because it looks like a quadratic. So actually all we have to do is hit the number 5. And if you want to do a best fit line, just so you can visually see, you don't have to do that. You need to leave it like this and then go into vars right here above tan, right next to the clear button, hit vars. And then up here you got vars and y vars. We'll go over to y vars and just keep it on function. Press enter. You'll get a list of your y's, which is in the y equals. Hit enter for y1. Doesn't matter which one you put. So I'm going to do a quadratic regression on L1 is x, L2 is y, because that's the default for the calculator. I don't have to tell it to do that. And I did put my x's in L1 and my y's in L2. And I'm telling it to find that equation and put it in y1. I'm going to press enter, and it'll give me my equation. And look, it did a best fit for me right there. Isn't that great? Yeah, that fits really well. I know it fits well because r squared, if r squared is 1, that means it's a perfect fit. My r squared is 0.999557799. That's pretty close to 1. And so I would write down, so what would I write down? Here's what I'd write down. See if I can bring up my notebook, and I'll probably, yeah, there's my notebook. Let's see here. All right, I think I can see those. So I'm going to go over here and I'm going to press pins. And then I'm going to, oh, I don't want that. I don't want that, sorry. I'm going to go over here, let's get away from that. I'm going to go over here and hit black, and I'm going to say, okay, my y is my distance, right? And that's usually x. We'll say delta x. delta x equals, okay, my first number is my proportionality constant. Because this is not a straight line, we don't call it a slope, but it's the number that goes with, it's the a, it's the number that goes with the x squared term. And it is 2.1. And if you'll notice, I had two significant figures and everything over here, but the first distance, and I meant to have 2 there, I meant to put 2.0, and I didn't, but let's pretend it's 2, so I'm going to have two significant figures in all my terms here. That's going to be, my x value is actually time, t squared, and then plus, no, minus 3.3 t, that's my x value, right, plus 2.3. Now, this is one of the equations we use to model objects that have acceleration, and this unit here, and you don't have to do this on the test necessarily for this part of the test anyway, but it's good to understand these things. My displacement and distance is in meters if we're in SI units. Could be in centimeters, but it's some kind of length, so we're going to just say meters. Well, this right here has to have the units so that it cancels out this one. We know that time is in seconds, so this is t squared, so it's going to be seconds squared. So to have meters here, I'm going to have meters per second squared, right? And that will, just to give you a visual here, that means that cancels out and I'm left with meters, right? So minus, and then minus the 3.3, so what does that mean? If time is in seconds, then this has to be, to get meters, because remember my answer is in meters, this has to be meters per second. And again, just to give you a visual, that means my seconds divide out and I'm left with meters. Yay! And then over here, I don't have any variable with this. This is standalone, so that means this is in meters because I don't have anything to multiply by. So what this is right here, this number right here is what, or this, sorry, this number with these units is what we call acceleration. All right, so this is acceleration. I can write, not very good at writing here. That's acceleration. That's how, that's the rate of change of velocity. In other words, it's how quickly or how much, not quickly, how much the velocity changes, all right? And then this one right here is my initial velocity. I'll just put VI for initial velocity. That's my initial velocity. And then this one right here is my initial distance. It's where I start, all right? So this is my initial displacement from 0. That's what that means. That's what that really means in real life. So it's ax squared plus bx plus c. In this case, we have a minus. So this object started out with a negative velocity, meaning it's going left. And it started out 2.3 meters to the right of 0, and it is changing its speed by a positive 2.1 meters per second squared. So 2.1 meters per second every second. And I hope that helps. I'll get out of this right here. And I don't want to say that. Hope that helps. And you will need to be able to take data, though, and put it in the calculator and just get an equation for the line.